Right, welcome everybody to our webinar today on solar panels on churches. Those of you who've been before will know that I always begin by giving you a quick trailer for upcoming attractions. So in terms of the webinars coming up in the next few weeks, we've got the last of the 3 runs of the housekeeping and quick wins for saving energy, really practical session on what you can get on and do very quickly that will save energy using your church. We've got the 3rd run of the session on electric car charging. Then we've got 2 more runs of solar panel for churches, one at 4 o'clock on Tuesday the 9th and one at 6 o'clock on Tuesday the 23rd of March. So if you get to the end of this session and think, oh, I really wish that these other people had been here and heard it, they've got 2 more chances to come along. And then in March, we've got the first running of our webinar on LED church lighting for saving energy, and the first running of our session on church heating to replace or not replace. All of the details of the webinars are on the Church of England website. If you do Google Church of England Net Zero webinars, but also once Guy gets going, I'll find the link and put it in the chat. Housekeeping things. Because we're doing this as a Zoom webinar, if you can type your questions into the Q&A rather than into the chat, that would be great, and we'll find them there in the Q&A. I've also had some sent in advance, so I've got those noted down next to me, and I'll weave those in with the ones that you put into the Q&A today. I am recording the talk, and the recordings will go up on our website in the next few days. And after today, I should look at Guy, just check this is okay. What I normally do, Guy, is send the slides around to everybody after the webinar. Would that be all right with yours if you make them into a PDF?
Yeah.
Lovely, thank you. And in that email, I'll also send you a feedback link. If you can click through and just tell us how the webinar was for you, that really helps me to make sure that the program's running well. So introductions, if you've been to one of our webinars before, you've probably met me. I'm Catherine Ross. I'm the Open and Sustainable Churches Officer in the Cathedral and Church Buildings Division of the Church of England, which basically means in that central buildings team, I lead on environmental issues. And our speaker today is the very experienced Guy Hewitt from Treadlighter. And Guy, you have been installing solar panels on all kinds of buildings for more than a decade, including many churches.
Yeah, that's certainly true. Yeah, absolutely.
So if I stop sharing my screen and hand over to you, Guy, to share yours and lead us on.
I certainly will. Thank you very much, Catherine, indeed, and welcome everybody. Good afternoon. Let me just say that I'm going to talk you through a few slides today. There's about 70. Some will take a few seconds. Some may take a little bit longer. As Catherine said, if you'd like to ask any questions through the Q&A, please do, and we'll come to them at the end. Just to say, my company founded in 2007. We've been designing, installing and maintaining solar PV systems on a huge variety of buildings for over 10 years. So without much further ado, I will now share my screen. And off we go. Okay. So today we're going to talk about an introduction to solar PV system for churches, what it involves, and try and give you some helpful hints and tips towards possibly progressing it for yourselves. But first, a little bit to do with the early history of solar. A lot of people think it's something very recent, but in fact it was in 1839 that the first effect of the photovoltaic effect was noticed by a research physicist, Alexandre Becquerel. And he was conducting an experiment late at night. He left 2 electrodes in a solution. When he woke up in the morning, the sun was streaming through the window and a small electrical current was being produced. And that was the first evidence of it. It took a further 50 years to get a solar module. And then Albert Einstein in 1905 was the first person to actually explain how the effect works. By the 1950s, the cells were starting to be produced, led by Bell Telephone in America. And by the end of the 50s, a rudimentary solar panel existed, but it was very expensive, $300 for a 1-watt module, where now we're looking at about $150 for a 300-watt module. So it took about 125 years for the technology to be advanced to the point where in the 1970s, there was a massive reduction in the cost, and every satellite that is circling the globe, virtually every satellite is powered by solar energy via photovoltaic fans and veils, wings, if you like, that power the batteries that maintain the systems on board. In the early 1990s, we started to see the rollout of solar panels, mainly for quite technical uses, but they started to become more widespread and used all over the world. In terms of just a little bit on the background of the market, up until the end of last year, there are well over 1 million installations of solar PV, and that covers everything from church buildings, schools, universities, domestic residences, offices, etc. 98% of all of the systems that are installed in the UK are below 50 kilowatts. Fair to say that a significant majority are around about the 4 kilowatts because they're on domestic properties. It's been in the news a lot, but the renewable electricity generation in the UK increased to close to 45% in 2020, which is pretty staggering. Now that covers obviously wind as well as solar. And we had a 67-day period in the middle of last year where we didn't burn any coal. And that was the first time for 200 years. So that's pretty good as we developed from pretty much a standing start 10 years ago. So what is solar PV? How does it actually work? As you can see, here is a PV installation. It's actually in North London, and it's on a drama school. Now, the system's solar panels generate electricity from daylight. They obviously work on a sunny and a cloudy day. They work harder on a sunny day, direct sunlight, because the incidence of irradiation is much greater. But they still work on a cloudy day. And so we're looking at how much electricity the system is going to generate over a 12-month period. The system size is very easy. It's just the wattage of the panels multiplied by the number of panels. So if you have 50 300 watt panels, you have a 15 kilowatt peak system. And the peak gives you a guide as to how much electricity instantaneously that system may generate. And that at this latitude in the world is going to be around about the 21st of June, will be its maximum output. It's a very robust technology. It is a true renewable in that it requires no other form of energy other than daylight to operate it. The systems come with very long warranties. All the manufacturers will now guarantee the output of the panel for 25 years, and the majority of the panels themselves have a 12-year product warranty, or the full to bits guarantee. It's fair to say that in over 10 years, we have never seen a panel full to bits. So it's a very, very robust technology, and properly maintained, there's no reason why these panels don't go on for a very long time. And finally, that the majority of systems, certainly at the smaller end, only require very periodic maintenance. So they're not that thirsty in terms of ongoing costs. The typical setup that you will find on any building, on the left here, we have panels installed, in this case, on a slate roof. You then have the panels produce DC, which you can't use in a building. You need to convert it to AC. And on the right here, you can see an inverter through to an isolator and then into the main distribution board of the building. So your rough components, without getting too technical in the system, is your solar panels, and they currently vary from 300 to 400 plus watts. And we'll come on to talk a little bit more about the panels a little bit later. Occasionally we'll need a panel optimizer if PV systems, if the panels are going to be shaded intermittently, that does affect the design of the system and it affects the output. So sometimes we'll need to use a panel optimizer to make sure it outputs as much as possible. You have your DC cabling down to the inverter, your AC cabling to your distribution board, a meter to monitor how much electricity you're generating, and then it's connected into the distribution board, and then any circuit on that distribution board can take advantage of the solar electricity that's being generated. So it's a reasonably straightforward, simplified setup, but that's how it works. Many people say, so what's the environmental benefit of a solar panel? Well, if you have a solar panel on a building, the building will always use the solar electricity before it buys anything from the grid. So for example, if your system is producing 5 kilowatts and your property needed 5 kilowatts at that instant to stay alive, your building is running for nothing. If you require less than 5 kilowatts, a small amount will flow out to the grid, the balance. And if you need more, only the balance comes in from the grid. So in this way, you can see that the amount of electricity that you require for the building in a year is going to be reduced because you're using your own electricity. So therefore, it follows that as less fossil fuel, whether that be gas or whatever, needs to be burnt to provide your building with grid electricity, there is a carbon saving there. It's very small, but when you multiply it up across the country, it becomes a large number. So by reducing the amount of CO2 emissions we need to generate electricity, it helps protect the environment. Another useful thing is that a PV system will contribute to improving the energy performance or the DEC display energy certification rating for a building. We often get asked this final question, which is how much, what is the embodied energy of a solar panel? And there's been a lot written about it. I've referenced the University of Utrecht scientific paper, but as a rule of thumb, it's 1 year's usage actually repays the amount of electricity that is required or energy that is required to manufacture a solar panel. So what's the financial benefit? Very few of us do anything unless there is a good financial reason to do it. The first off is that you are going to save some money off your bill because you're using your electricity that you've generated, and obviously you need to express that against the cost of installing it. You can also be paid a small amount through your electricity provider for any electricity that is actually exported to the grid. And we'll come on to explain a little bit more about that later. So if you add together the cost saving because you're not buying so much electricity from the grid and the small payment you may get for anything that is exported to the grid, you have a total saving, if you like, a total benefit for the year. All installers will then use a government inflation rate, fuel inflation rate as per the government's forecast, to calculate a return on investment. And we find that at the moment that varies between sort of 5 and up to 12+%. It follows that the more of the solar electricity that you can use in the building in the daytime, the greater the saving you will make. Now, we spoke earlier about being paid for export. Without going into too much detail, if you have a PV system installed, you will need a smart meter, which will be able to record any electricity that you generate that flows out to the grid. And through your electricity provider, you would apply for what's called the Smart Export Guarantee. And that currently pays round about 5.5 pence per kilowatt hour. So you would be paid, as it's measured, you would be paid via your electricity provider. So let's have a closer look then at solar PV panels. I'm sure you're all familiar with them, you've seen them. All black panels are now becoming the standard, really, unless a system physically can't be seen. It's very important, any panel that is used, any component that is used, must be approved by the Microgeneration Certification Scheme for use in the UK. And that's principally tier 1 manufacturers, not only in terms of the quality, but all the panels are what's called flash tested under a bright light to make sure that they do actually generate what they say. As I said earlier, the panel wattages, the standard wattage for a solar panel is somewhere between 300 and 400 watts. The larger end of the scale at 400 watts, the panels, the physical dimensions do tend to get quite big, and they would only be used in very large installations, probably ground mounted. So somewhere between 300 and 360 watts is what you can expect the panel wattage to be. It's important not to get too tied up in the efficiency of a system. The efficiency of a solar panel primarily dictates its physical dimensions. 10 years ago, a 1.7 by 1 meter panel would have been around about 200 watts. Now we're looking at 350 watts. So we're getting more electricity generation per square meter. There are some minor differences in panels, but they're not great, and they're only for very specialist applications. Provided your installer is an MCS accredited installer, they will be using the right equipment. Traditionally, panels, as we know, on the top here, you can see the traditional blue and silver white backing sheets, but these are now, we're finding that black panels are a better use, certainly for things like churches and sensitive buildings. Principal applications of solar panels include inclined roofs. As you can see, here's a church in northwest London. Around about a 10 kilowatt peak system in all black helps them to disappear. We can install on flat roofs. Now, on flat roofs, we don't want to puncture the roof for obvious reasons, so we use a self-ballasted system. And that's carefully calculated to make sure on wind lift that it stays exactly where it is. If you are going to be replacing a roof and retiling a roof, then it is worth considering an in-roof mounting system. It doesn't quite put the panels absolutely flush, but it does inset them into the roof, and you don't need to have any tiles underneath because a special flashing system is used. This does provide a very aesthetic solution. And finally, if you're lucky enough to have the land, you can also consider installing panels on the ground. And here's like a 10 kilowatt system. And then you can have fences around it to screen it as well. So we often get asked, crikey, how do you actually fix the panels to the roof? The answer is that there are roof hooks, specialist roof hooks made for every different type of tile and every different type of roof surface, from zinc through to slate tiles, clay tiles, pan tiles. And the way we do it is we carefully remove some slates, we locate the rafters, we then insert the roof hook into the rafters, we then replace the tiles, making sure they're properly weathered. And what you end up with on the bottom right here is a series of roof hooks running across the roof onto which we bolt rails, and then the panels are mounted onto them. So quite a straightforward process. And as I said, there is a specialist roof hook for every different type of roof surface. So enough of the sort of technical side. Let's have a little look and see what's involved in assessing suitability for churches, because quite a lot of things that you can actually do yourself to make things quicker and easier, and also to inform any installer that you might want to consider helping you and providing quotes and system designs. It's fair to say that many churches have an east-west aisle, and therefore they would have a section of roof that is southerly facing and could well be useful and applicable for the generation of electricity. But we have to bear in mind that many churches are well over 100 years old. They could be enlisted in conservation areas. They're very much a feature of the local amenity. They often have slate roofs, and we've encountered many roofs that are actually original. They may have been patched up, but they are original. And also we find that over the years, many different types of supplies have been added to the church. And this is an important, very important issue here, because to benefit, to the maximum benefit, you want any circuit that is connected to the distribution board or the meter to be able to benefit. So sometimes it may be a good idea to rationalize your supplies. Not only would that save you money on standing charges, but also it gives you one supply, which then serves the building. We then have to look and see, is the church listed or not? Is it in a conservation area? Do we have a section of roof that we think is relatively unshaded and could be used? Bear in mind that roofs don't have to be directly south-facing. East-west is also a very good way of doing it. On a really shallow roof, we can even look at north-facing roofs, sort of down below 10 degrees, really. And then perhaps as importantly is to ask, you know, how visible would panels be from the public highway? That's one of the judges that is made. And then finally, you know, is the roof in good condition? Does it need a lot of repair work? Obviously, if it does need a lot of repair work, then that would need to be considered. And again, your installer will be able to give you a good indication of that, but you may need to refer to a specialist roofer upon their advice. As a rule of thumb, solar panels weigh 20 kilograms over a surface area of 1.7 square meters, and their imposed load on a roof is not great, but you will need to check, and we'll come on to that a little bit later. So by having just a few thoughts about some of these things, you can probably narrow down, you know, whether solar is likely to be something that you could conceivably look at. Other things that need to be costed in, and it's very important that your installer does include things like the cost of scaffolding, what type of electricity supply, is it single or three phase? That will determine to some degree what can be installed. Very importantly, to give your installer or potential installers, how much electricity does the building use in a year, and how much do you pay for that electricity per kilowatt hour? We all pay around about the same, but if you can be accurate, this will enable your installer to be much more accurate on the type of benefit that will accrue to you. And then finally, and also very importantly, is what is the daytime occupancy of the church like? Is it in use day? Are there the meetings from all sorts of types of meetings? Are there play groups? Whatever, what is going on in the church during the day and during the evening? And then finally, do plans exist for the church? It's a difficult one, and we find very often that that they don't exist, and so they will need to be drawn if planning consent is required. So let's move on and just talk a little bit about planning and consents. Local planning consent is required for any church within a conservation area. If the church isn't in a conservation, it is sensible to get to apply for a lawful development certificate to absolutely make sure that the system could be installed under permitted development rules. So we highly recommend that, and we found that the DAC will almost certainly require that, and you will need a faculty. Now, listed churches have an exemption for the need for listed building approval, and that responsibility actually passes to the diocese, and they will need various documents supporting your application. And just bear in mind that obtaining all the consents that are required can take from 3 months to well over a year. But stick with it, because it is possible. For buildings that are listed or in sensitive conservation areas, we would strongly recommend that you elicit the services of an architect, particularly where plans are going to need to be drawn and created. You are going to need detailed plans when you submit to the council, and almost certainly to the DAC, and you will need a heritage statement. If the system is going to be visible, it doesn't mean to say that it will be refused. However, there is going to have to be quite careful reports written, if you like, to support that the public benefit will outweigh the harm to the heritage. So we do recommend that the services of an architect, you may have that within your PCC or congregation, but it's something that we would strongly suggest you consider. The minimum amount of drawings that you are going to require, and to the right here you can see a couple of drawings we prepared earlier. A site plan, we need to see where the church is exactly. We need a roof plan as it exists, as it proposed. We need elevations, and we'll need photographs from the surrounding area to support the application. The diocese and almost certainly the council planners will require a written document which will be illustrated, and this will cover obvious things from the history and development of the church, significance, and what the impact of the proposed works is likely to be. In some circumstances, they may require a 3D model. Now, these can be bought and then adapted, and the cost does vary as to the level of detail. We don't find this is all the time, but it can happen, particularly very, very sensitive areas. Finally, the council planners are now wanting to see that church buildings have taken reasonable precautions to do what they can to conserve energy. So just beware that you may well be asked about lighting, your insulation and heating to see what you have done or are planning to do in order to improve the efficiency of those parts of the building. Finally, having said earlier that the static imposed load of a solar panel is actually quite low, which it is, you may very well need to get a structural survey prepared by a local structural engineer just to confirm in writing that the roof will accept the load. And you can look at CARE, which is the Conservation of Accredited Registers of Engineers, and find a local one to you. And as it says on the slide, you can expect to pay somewhere between $500 for a straightforward roof to $1,500 for something a little bit more complicated. Right, in terms of the installation, it really does come down to the location of all the cabling, and all of that will have to be detailed exactly as to where it's going to go and how. And you can see here we are dummying up things to show, to make a visual record that will accompany the application to show how everything will look. And then finally, in architectural fees for simple buildings, 2,000 up to maybe 8,000 for complex buildings. But also you need to factor in site visits, advice, meetings, preparation and submission of all planning documents. We've even had to mock up an installation on a roof with a panel so that the council could come down and look at it from the street and all different types of angles. Now that was on a grade 2 star listed building, so hopefully that's not for every different type of church. So let's have a little quick flick through the process in terms of the various stages that you could expect in looking at solar PV. Once you've selected some installers that you'd like to invite to tender, if you like, they should all be able to give you a preliminary assessment using Google. If you can give them, as we said earlier, your usage per annum, what you pay, and the occupancy level of the church, they will be able to prepare for you a very good indication of what they think would be possible and why, the likely cost for the installation, and what the ongoing benefit for the church is likely to be. That then should enable you to make a selection of one that you'd like to possibly move forwards with, and they will almost certainly want to do a more detailed site survey so that they can then prepare detailed systems design and an actual formal quotation for you. You then will need, obviously, to get PCC approval. You need to go through the planning consent process and the faculty. You may need architects, structural engineer, models possibly, as we've said earlier. And then once you've got your permission, we come down to the easy bit, actually, which is the preparation for the site, the installation, and certifying the system. And then there follows very periodic maintenance and monitoring. Suffice to say that you'll benefit from all the manufacturer's warranties as well. This provides an example. This is the sort of thing that you could expect to get, a preliminary assessment looking at a church. We've indicated here where we think that the panel's mostly likely. You can see that we've steered away from the main southeast facing large roof of the church because it fronts the public highway in a conservation area. And from that, we're able to give them an estimated system size, a rough indication of what it might cost and what the benefit to the church is likely to be over time. I'm not going to go into too much detail, but your installer will be looking at all sorts of things that determine the design of the system, how much it'll output, and all the other issues that go together. So I'm not going to go into all of that in detail now, but there's a fair amount of things that they will be coming to you and advising you on and giving you assistance with in order to end up with a workable solution. You can expect to see a roof plan indicating where the panels will be. In terms of the output of a solar PV system, it depends on a number of things, but we ultimately use actuarial data of the amount of solar irradiance over a particular postcode. And that is used to factor in, using MCS methodology, the output of a system on average per annum. Nobody can be 100% accurate. Nobody knows how many beautiful sunny or winter days we're going to get, but using the average of 20 years gives a pretty accurate forecast of the generation that you can expect. You may well see a shading chart like this. In this case, there is no shading over the area. where you can see this is arbitrary example. This is nothing specific. An 18 kilowatt system. The postcode region is zone 1. This tells us that the array is a southeast facing array. We take 0 as south, minus 45 would be east, plus 45 west. The roof is inclined at 25 degrees. And then the tables calculate that for every kilowatt peak, you can generate 919 kilowatt hours. There's no shading, and therefore the system is forecast to output 16,542 kilowatt hours. So that's the sort of detail that you'd be looking to see. And then again, purely arbitrary, we're looking at forecasting what the benefit is going to be in terms of a financial benefit. So we've got a system size, we've got its output, and then your installer will need to make a forecast using a methodology of how much of the electricity that is generated you are actually going to use in the building. And then that's multiplied by the average price that people pay, or the exact price that you currently pay, if you can provide it. And then the balance, the 15% balance in this example would flow out to the grid, and we've used a figure at the time, which is the average amount being paid by electricity companies for you supplying them with your excess electricity. That gives you, added together, gives you an annual benefit and the amount of tons of CO2 that the system is saving per annum. In terms of the payback and return on investment, yes, we do things for different reasons, mainly to help the environment, but obviously it's important. We would have the fully installed cost, in this case excluded VAT on this one, because it was a commercial installation where they could reclaim the VAT, and many of you may not be able to do that. It then gives a forecast on return on investment. In this case, it's quite high because these people are using 85% of the electricity, and that in turn relates to a payback period. And then you can expect to see what sort of benefit over 20 years this is going to deliver. Okay, in terms of actually installing these systems, majority of systems take between 2 and 5 days. You can expect a pre-installation, technical site survey. You've got scaffolding to go up and be certified and secure. Then you've got your cabling, your installation of the panels, leading through to grid connection and commissioning the system, and off we go. And as soon as that system is turned on in the daytime, it starts generating electricity and your church will benefit. There's a lot being spoken about battery storage systems at the moment, and obviously the concept is very simple: store your excess electricity generated in the daytime and use it when the sun goes down in the evening. What a battery actually does is it just increases your self-consumption percentage of the solar electricity generated, assuming you're not using it all. But you need to be very careful in how you actually calculate and how you work out whether a battery is actually going to be of benefit for you. I mean, there is no point in having a battery if you're using all the electricity that the solar PV system is generating. And if you're generating more, but you're not using any in the evening, because you've got no activities going on in the evening, there's not much point in having a battery either. So one has to be very careful. And I would just say, there is a potential for mis-selling here, and it's very important that you get proper advice from an MCS accredited installer here. In principle, don't get me wrong, they're a very good thing and they can be very good, but you have to be very careful about the sizing of the battery and how much benefit you're likely to get. So it does have good potential, particularly if churches perhaps are less busy in the daytime, but they're more busy in the evening, for example. Then you could be sizing the PV system so that it just produces enough electricity for that purpose. Batteries are coming down in price. They can be retrofitted easily. We are expecting the technology to develop very much like solar panels did as the uptake increases. There is a very slight price benefit installing at the same time. It's not huge at the moment. Some suppliers are also allowing you to charge up your battery in the middle of the night at a lower rate, but obviously if you've got a PV system, that may or not be relevant to you because it's going to charge up in the daytime anyway. And at the moment, you can expect to spend over £3,000 for a 6 kilowatt hour battery at present. So let's move on to a few selected case studies here. Before we start, it's always dangerous to quote system costs because things change over the years, and some of these installations were done a while back. Some of them were done when there was the feed-in tariff that paid you for generating electricity. That doesn't exist anymore. Every single installation is unique. It's very straightforward. There are virtually no properties, certainly churches, that are identical, and we have to be mindful of each church's circumstances. Some may be occupied in the day, some more in the evening, so we have to be very careful of that. So just when you see the prices that are quoted here, please understand these come from quite a long period of time. Please explore any grants that there may be available in your area. We've had several times when local councils have, for example, been able to give a grant for the addition of a battery. So let's look here at a grade 2-star listed church, St James's in Clerkenwell, right in the edge of the City of London. A very nice south-facing roof, as you can see, but a prominent location in a very sensitive site. Very detailed site survey carried out with an architect appointed. The church had also recently upgraded their lighting. We actually assisted them with insulating the loft as well. Council planning consent was eventually granted along with faculties, and it took 9 months. As you can see, a nice large south-facing slate roof, which is actually in pretty good condition and relatively unshaded. Islington Council required us to do a complete mock-up using an actual panel and dummy panels to make doubly sure that this system couldn't be seen and would be invisible from the street, given the sensitivity of the local amenity and surrounding area. This resulted in the panels being carefully positioned, as you can see, above the parapet shade line at the bottom. So we want to make sure that it wasn't going to be shaded for half of the day, the bottom edge of the panels. All black panels were used to further minimize any visibility, even from higher buildings. And as you can see, with a flat roof right in front of the panels, easy access for any potential future maintenance or cleaning. Just over 7 kilowatt system was installed in the middle of 2019. The system's forecast to generate just over 6,500 kilowatt hours and save just 3.38 tons. The annual benefit to the church, this particular church has a very high daytime load, and it uses 99% of the electricity that the PV system generates, and therefore quite a high return on investment follows for that. Another church, again in Islington, the grade 2 listed and in a conservation area. Interesting to note with this church that there's very, very limited visibility of the main south-facing nave roof of the church. Nevertheless, planning consent was required, and we went through all the processes that I've outlined earlier. And in addition, the church, which has a large facility for homeless people, upgraded the whole of the church and the associated offices and buildings to LED in order to show and demonstrate their energy efficiency program. Large unshaded south-facing slate roof, and the building again has a very high electricity demand because of all the daytime activities that take place. 18 kilowatt peak system we installed in the spring of 1919. This generates a lot, 16,500 kilowatt hours. Now, because the church uses a lot, they use almost all the electricity that is generated, they do get close to 10% return on investment. So that was a very good use of the technology, given the high daytime usage. So St Augustine's Church, another large, very large Victorian church in Highbury, not listed, but in a conservation area. Suffice to say, there was hundreds of meters of square roof that could be used for solar PV. The church has a high daytime occupancy, and they have a high electricity usage. I believe they have some offices and nursery school, various other activities going on. there were a number of different supplies in this church, which was costing the church a lot of money. What we advised was that we should rationalize these to one supply going through one distribution board, which then enabled the PV system to be connected to one supply, and any of the circuits that are connected to that distribution board could benefit from the solar electricity. As you can see, this is part of a drawing that was a photograph that was submitted with the planning application. As you can see, there's a very large south-facing roof, but the planners preferred the chancel roof, which also provided a very good location for a PV system and is slightly less visible. A lot of the cost in these systems can be scaffolding, particularly on very large roofs. In this case, we're only installing on the chancel roof, not the whole roof. And the services of a cherry picker could be used to run the cable discreetly under the eaves and into the bell tower. So the use of the cherry picker, particularly for things like future maintenance and cleaning where it's difficult, is something to consider rather than scaffolding the inverters in the bell tower. And I hope you'd agree that gives as aesthetic a look of a PV system with all black panels as is probably possible. So just under 11 kilowatts, again installed in the spring of 2019. Gives a substantial benefit, generating 9,200 kilowatt hours per annum and an 8.3% return on investment. Again, the church uses very significant percentage of the electricity that's generated. Moving on to a completely different type of church, which is not listed and it's not in a conservation area, and it has a north-facing roof. In this case, we needed for the DAC to get a lawful development certificate to be absolutely certain that the authorities would enable the system and allow the system to be installed. And having got that, then faculty was applied for and duly granted. This church happens to benefit from a large roof that's not that steep and it faces northwest, but it's very unshaded. And so actually, when we looked at the design of the system and their usage, it does actually make good sense. Again, all black panels used to further, and they look pretty good on a slate roof, it has to be said. Being only one story up also makes it quite straightforward for cleaning. A lot of window cleaners will now have telescopic cleaning poles that can easily reach up to this sort of height. Again, 12 kilowatts, a high usage as well, lots of daytime activities and offices, etc. in the building, delivering a nice return on investment. Then moving back to another grade 2 listed church. This is in the middle of Chelsea. As you can see, this church actually has a butterfly roof to the south of the bell tower there. This process took a long time. I can't hide the fact it did take over 12 months to get consent from the local council and the DAC. But as you can see, where we had the facility here to install the panels in such a way that they would be completely invisible for street level. And here gives you an example. We'd like to have used a bit more of the roof, but of course we weren't allowed to. So a smaller system was installed. Again, the church uses a reasonably significant percentage of it. It's got a nursery school attached to it that's operating in the daytime, of course, as well. And delivers a reasonable return on investment as well, without harm to the local environment visually. And I think this is the final one. Moving on to a modern church, striking modern design, 1958. Again, not listed or in a conservation area, but a lawful development certificate was applied for and gained along with a faculty. And in this instance, and this is something that is worth considering if your church does have associated buildings, that we did actually install this system on the church hall roof, and then it is wired back to the main supply to the church. So obviously it provides power to the church. And again, we used all black panels to help with the aesthetics of the system. Again, this one has a high, this particular installation was at a time when the feed-in tariff was in, which is why you can see the annual benefit is £1,400 odd and nearly 11% return on investment. It's possible to get up there nowadays, but mainly for buildings that use a lot of daytime electricity. So some of this may sound a bit daunting. There's an awful lot of processes to go through and permissions to get, but actually if you follow the process through, you know, I think the motto "keep calm and carry on" is a good one. Here's an example of an unlisted church in Nottingham that's got very, very visible panels and for which permission was granted. So it is possible. One just has to follow the process and you know, and make the applications and make your case as well as you possibly can. And so to summarize then, in terms of the first steps, firstly, review the MCS, that's the Micro Generation Certification Scheme list of local accredited installers, and you can then look at their work, I'm sure, through their websites, talk to some of them and select those that you may wish to consider. Beware of internet pop-ups. There's lots of all sorts of advertising going on, that just if you refer to the MCS list, you can be certain that they are accredited companies. There's a good place to start is to request an initial Google desktop assessment of what may or may not be possible. If you give them your grid electricity usage over the last 12 months and how much you pay for electricity, together with what sort of occupancy your church buildings have, then that will enable an installer to give you a pretty good indication of what they think is sensibly possible, considering any planning issues, the likely cost and the sort of ongoing benefit that you may expect to accrue to the church. So there, I hope, is just an introduction to the processes and for considering solar PV for churches. Thank you.
Thank you so much, Guy. What an enormous quantity of incredibly useful information. So we've got 13 minutes and a lot of questions.
Right, okay. I'll do my best.
If you can open the Q&A box on your screen, then that'll give you a chance to skim them. Can I ask everyone who's joined two things? One of which is, if you asked a question, but it's been answered as we've gone along, can you remove it from the list so that we don't spend time if it's something that you feel has been adequately answered? And also, you can click the thumbs up next to those questions that you would most like to hear the answers for, and then those ones will go to the top, and I'm sure that's where Guy will naturally start. So remove a question if it's been answered and vote for the ones you really want to hear for. Whilst Guy has a skim, I'm going to answer one where I'm better placed to be the answerer, and that'll give Guy a chance to read the questions you've asked, which is one that came in by email in advance, saying the Church of England have recommended suppliers. So the answer on that is no, not at the moment, but it's something that we're actively working on. So our central procurement arm at Parish Buying are currently putting in place a pilot with one diocese to look at doing central procurement for solar. And if that goes well for that one diocese, then over time it will roll out. So no, we can't at the moment say here are our recommended installers or our recommended types of panel, but it is something that we're actively working on and that will come in time. So Guy, let us have a look. The one that has come to the very top seems to be to talk about community solar. Is that something you can?
It's not something we know an awful lot about, to be honest with you. We tend to, that type of, are you talking about getting funding, or are you talking about participating?
I suspect that they mean when the panels are fundraised for by the community and then installed on the church, and then there's a return to the members of the community who've invested in it. So like Power Up North London have done on, is it St Anne's? And recently that's the route to the panels that went on Salisbury Cathedral cloister roof has been through a local community energy project. So the cathedral is benefiting from cheaper electricity, but any income from the panels is going to the community energy company. Okay,
well, I mean, that would have been done when there was a feed-in tariff. If there's no feed-in tariff at the moment, then there is no income. The only income would be some form of export income.
So I think the way, because the one on the cathedral went up this summer. So
Right.
it's happening in some places. I think what's happening there is the cathedral is still paying for the electricity. So that's the income that's going to the community energy company, but they're paying less than they would have done to just buy their electricity on the open market.
Right.
And then there's a little bit of income, isn't there?
I'm not sure there's much I could really add to that, apart from the installer would need to price that system for you. And I'm not really certain it's something that we really get that involved in. We'd be happy to. How the money is generated in terms of the capital cost of the system is not something that we have hitherto become involved in as a company, because that's done by the owner of the system or the organisation of the church. So the honest answer to that.
If that's not your area of expertise, let's move on to the next question.
Okay. PV slates. PV slates are very expensive. When we last looked at this, there wasn't a PV slate that was MCS accredited for use in the UK. That may have changed. They are expensive. They do look very good. But when you compare the cost of PV slates to in-roof PV panels, then there is quite a difference in the cost. And we find that a lot of people, particularly if you're using all black panels on a grey slate roof, you can find that that is a vastly more economic solution. Not to say that they don't exist, PV slates, but we don't know. There used to be 2 or 3 manufacturers. Because there wasn't a great call for it compared to the amount of solar panels, then I believe that when we last checked that the manufacturers had actually let their MCS accreditation drop. So be careful, make sure that whatever you're using is MCS accredited, and you can check that through the website. Can you give a ballpark idea of total cost to install? Is it in that? Well, I've given several ideas during the presentation of what it costs.
Yes, that question was entered quite early on. So before you'd got to those slides.
So hopefully that's been answered already. You know, it's almost impossible. I mean, how much scaffolding is going to be required to get up there? Is it? I mean, I couldn't give you an exact figure, to be quite honest with you. I mean, if it's a £1.50 a watt, if you want back of a cigarette packet idea, something like that, excluding scaffolding, you're not going to be far wrong. So 8 panels, 3 through 8, 24, 2.5 kilowatt system. I don't know, 5,000 plus the cost of scaffolding and access and any form of permissions and planning consent, something like that. It's very difficult to say though. And, you know, cost is obviously very important, but it's more important to get the right solution for your particular circumstance. And that's why things like the amount of electricity used, the occupancy level, they're very important information.
And I think it's right to say, isn't it, Guy, that if a church gets a free desktop survey, which is a brilliant thing to get done first, those don't generally include the scaffolding, do they? So that would be one thing just for the church to keep in mind, is to take the desktop survey and then add on what they, for example, if they've had roof work done and they had a sense of how much scaffolding cost them for that, that would probably give them a good sense.
Yes, I think that's very good. Some installers would be able to give you a ballpark figure for it. Of course, you've got a local scaffolder that you could go and ask. I mean, they're all there's loads of local scaffolders. But yes, in principle, they'd be looking at the system itself and what's involved in installing it, probably with the exception of the scaffolding, and they would be right to reserve the right to come and see that properly. So I think that's sensible, yes. How mature is the tech? This is what we get asked a lot. If you go and buy a TV today, the minute you walk out the door with your TV, it's obsolete because a new model is being built. So you can only really go on what exists. Now, over the last 5 years, we have seen, don't worry too much about the efficiency of the panel, 20% is pretty good. All we're seeing really is more watts per square meter. So the panel remains around about the same dimensions, but it will output more. But you know, the minute you've got your PV system on the roof and it's generating electricity for you, you're saving money. And you're putting it in at a time when those calculations have been done, you know what you're doing, you know what the return on investment is. If that makes sense today, it's going to make sense. I wouldn't worry too much. We're not expecting all of a sudden that, you know, a cigarette packet size solar panel suddenly outputs 500 watts. That's not going to happen in the near future. There's lots of technical developments coming around, but really we're just looking modest increases in the panel wattage. What's this? We have a lead roof. We're situated in the conservation of the church is grade 2 star listed. A lead roof, right. I'm not sure how you would fix to a lead roof. It's certainly possible. It depends what happens underneath. I think one would need to know a little bit more about the roof makeup there, what's underneath it. So possibly get the advice of a roofer as well on that one, I think. So not necessarily a non-starter. I haven't personally encountered a solid lead roof like that. If it's got a standing seam to it, it might well be possible. So a little bit of exploration there. Giles Goddard, other improvements in PV panels. Well, I've kind of explained that. Panels are about as, well, they've actually got more expensive since January the 1st, would you believe it? And we are seeing at the moment delays in importing panels because of the increased bureaucracy at the border, but that's not for discussion here. There are modest improvements. I very much doubt they'll be in costs. I think costs are possibly likely to increase slightly, certainly for the next few months. But as I said before, if it makes good sense to put panels on your church or your church buildings, it makes good sense. And why wouldn't you start now? And why wouldn't you start getting the benefit? I don't think this, I can't see anything that is coming up immediately that is going to change that dynamic too great. Okay. Includes seagulls. Now that's a good one. Bird proofing is something that we definitely recommend now, and we do it by the installation of a specialist wire mesh around the perimeter of the array. It stops birds getting, mainly pigeons, but obviously seagulls too, although they're a bit bigger seagulls, and the panels are only about this high off the roof. But it is certainly very sensible to include bird proofing, particularly on a hard to reach roof. The solar panels have a self-cleaning coating to them, which with normal UK rainfall keeps them pretty clean. If you are in a very industrial area, they may need a clean every 3 to 5 years, provided it's safe to do so. You can think of a cherry picker, which is not desperately expensive to hire for the day. Alternatively, there are many window cleaning companies that have like 65-foot poles that will be able to clean from quite a distance. So
is it the kind of thing that if you are having the person come to clean your gutters, is it the kind of thing that they could do whilst they were on site?
Yes, absolutely. Absolutely.
It's not it's literally just giving them a clean. It's not a technical job that you need a solar company for.
No, you need a soft brush just with water just to brush off. You do sometimes find a little residual dirt build up along the bottom edge of the panel. Bird traffic, as we call it. Now, bird traffic is generally washed off by, the average amount of rainfall we get in the UK. If you're very, very unlucky and it gets really bad and you've got a squadron of geese going over, you may want to consider cleaning them. Okay. How can we select a supplier without already having a technical if grant bodies require 3? Okay.
There's one higher up actually that I think got skipped unless I missed it, which is about, is there any concern or data on theft and vandalism to solar panels?
Well, the majority of panels that you'll find on churches are high up on roofs and they're extremely difficult to get to. And I've never, ever heard of any form of theft or vandalism there. Where we have heard stories on ground mounted systems that aren't properly protected, but I've not heard of it. There's very little you can do. And of course, you've got to be careful because in the daytime, they're live. So anybody who wants to come and mess around with them is likely to get into trouble. So the honest answer is, I haven't really got any proper data on that. I've no doubt it does exist, but I haven't heard it, and it must be extremely rare because we've been around a long time. We probably would have heard about it.
I wonder whether actually, certainly for churches with metal roofs, whether it might actually help with reducing the likelihood of the metal theft from the roof, because actually it makes it more difficult to steal the metal, doesn't it?
Yeah, absolutely. We sadly do hear of that, and we do see that. But yes, I think it might do. Let me answer a question from Nigel.
I'm just conscious, guys, that it's 1 o'clock.
Okay, well, I'm happy.
Really, there's some questions left. Are you happy to give me another 10 minutes, Guy, if people are happy to stay?
Yeah, I can just go down some of these questions.
That'd be lovely. If I say to the audience then, if you need to get away promptly at 1 o'clock, thank you for coming and please do go. But
No,
if you've
thank
still
you.
got a question in the list, Guy's going to give us another 10 minutes, so hang on.
Okay, let me answer Nigel. What is the lifetime of the inverters? Well, all inverters have a 5 years, they vary according to the manufacturer, somewhere between 5 and a 12-year standard warranty, where if the inverter was to fail, and there is no reason that it would do, but there is a mean time between failure for all electrical devices, then the inverter, the actual cost of the inverter, the equipment will be covered under warranty, and there'll be a small charge from your inverter to come and swap it. So the answer is we have solar PV systems, quite sizable systems that have been operating for 10 years without any problems at all. We have some installations, we put the inverter in, it goes down after a month, we replace it, and we never hear from them again. So the answer is that you're very well protected. You can buy an additional warranty if you like, so you could extend your warranty for a few £100. But I can't give you an absolute answer to that question. Suffice to say, it's in the manufacturer's interest to keep their product working, and therefore, provided you are in the warranty period, it will not be expensive to upgrade them. Which will church roof require strengthening in order to install solar panels? That is only something that you would need to get. Your installer should be able to give you a pretty good indication of that. They're not generally structural engineers, but they are trained to look at the size of the purlins and the rafters and to make a preliminary assessment. If you want that in writing, you will need to get a structural engineer.
And I would say on that, the faculty applications that I've seen come through, generally the church has either been asked by the DAC to get a structural survey, or the church itself has chosen to get a structural survey so that they have that confidence, because you don't want to put an expensive piece of equipment on a roof that you aren't sure can take it. And it's also that you want to have a roof that's in good condition. If your roof is going to need replacing or major works within the lifetime of the panels, it doesn't make sense to put the panels on until you've had that work done.
Yeah, absolutely. What are the advantages of installing a battery to store? Well, the advantages are that really would be if you're using a lot of electricity once the sun goes down. Ideally, in an ideal world, you'd want to have a PV system that is sized to cater for your average daily usage all the time, have a little bit of excess that gets stored in the battery that doesn't go out to the grid that you then use in the evening. But there's no point in putting electricity in a battery if you're not going to use any electricity in the evening. So it is a calculation, you need to be careful, and it can work. The prices are coming down. We're not finding it makes a massive difference at the moment, but we think that as the longevity of the batteries increases and their guarantee period, and the price comes down, it will start to make good sense. But you should definitely consider it and look at the numbers.
And Guy, I know that we've been speaking to churches when they've been coming through for faculty applications about making sure that even if they're not doing a battery now, that they install it with a mind to putting in a battery in the future. So it's kind of battery ready. They've thought about where would it go and where will the cable runs be. Yes. Is that something that you would agree with?
Yes, it's something I would definitely agree with. It's something that we would look at, certainly, and any good install would look at on a survey. Also, what's happening, and this is quite a new development, is that the inverters are being made as hybrid inverters. So they are already battery enabled. It doesn't matter if you have a PV system and you add a battery system to it later. It's a tiny bit more expensive because you need a different type of inverter to convert the stored electricity back to AC for use in the building, but it's not a deal breaker. But yeah, I'd certainly agree with you. Yes, to look at it in the beginning. Are there companies that will manage the whole process? It's kind of impossible for people like us to manage the whole process because we don't own the supply and we're not the church and we don't have the knowledge and the expertise of the church. But certainly a good installer will be able. I mean, if you make a decision early on to go with an installer and engage with them, they know that they're going to be doing the installation. It makes it all the more easier for them to give you more time, more advice, but we can't do everything, unfortunately, but we can help guide you for certain. What are the benefits of an installation with a low diatom electric use in a country church? Okay. In that type of instance, it may well be, it depends what you do in the evening. If you do have evening use, then it may be useful to consider a battery there, or maybe you just wouldn't put in too big a PV system. the other thing to do is look at the amount of electricity that you use in a year. Maybe you would design your PV system to generate 25% more than you use in the year. And then you can say that this church is carbon neutral on electricity. We generate more than we use. Now, that doesn't mean to say you won't get a bill, because you may well be using electricity when the sun gone down and it's not coming from the PV system unless it's a battery. But it does give you that ability to say, honestly, to say we generate more electricity than we use, and that's a good thing. I don't have any specific issue. Are there any specific issues in rural areas? Yes, I mean, obviously areas of outstanding natural beauty are going to be like Grade Star listed buildings, you know, and the effect on the amenity is going to have to be very carefully considered. Again, I think that's something that a local architect will be very helpful to people on. Solar PV companies are not planning experts in terms of, you know, all of those things. Is the church working to reduce the effort required for permission? That's not something I can answer, really. I don't think.
Sorry.
You can help out with that.
In terms of, absolutely, yes, it's a discussion we're engaging with, but it will take time. So we're engaging actively with the amenity societies, with the Victorian and Georgian Society and SPAB and Historic England. And each of those organisations is grappling with the fact that they recognise the climate crisis, they see the importance of it, but equally they want to protect our heritage. We are positively engaging with it within the church. So we've got a paper coming to Church Buildings Council just this week to talk about visible solar panels and test the water at Church Buildings Council about how far views may have changed in the light of General Synod's declaration of net zero. So I would say absolutely we are aware of those issues. We're very aware of the fact that when people are making decisions, faculty or planning, they're weighing up the public benefits of the panels against the harm to the heritage. And that in the light of the climate crisis, you can make a very strong argument that you should put more weighting on the public benefit. So again, a little bit like I said at the beginning, that these conversations are ongoing, and watch this space.
Okay. Yes, we do use battery systems. How does your building know to use your PV before grid electricity? It's a good question. The inverters are connected to the grid. They have to see the grid all the time. They are effectively controlling. They know how much electricity the building is currently needing, and they know what is being produced from the roof in many cases. And so if one is more than the other, they know that they're using the solar electricity, and they will only allow electricity to come in from the grid if not enough electricity is being produced by the panels. My business partner could probably give you a more technical reason, but that's a very simplified view. What are the considerations for PV on
I should feed in a couple of the ones that came in by email.
Okay. Yeah.
I suspect this one is kind of, well, let me just go for it, which is, what is the effect of a cloudy day? We've got our solar panels on, it's a cloudy day, are they still working? Okay,
right. Middle of June, sunny day, systems will be outputting, you know, you never get 100%, 95% of their theoretical output. On a horrible grey January day, 5%.
So do you mean their output reduces by 5%, or do you mean you only get 5%?
You only get 5%, 95% less than you would in the summer. But you've got to be very careful here, because a nice bright winter's day, you're going to get quite nice generation as well. So it's very important that your installer will calculate for you what they can forecast the annual output of the system to be. Now, if you can give me half-hourly meter reading from your electricity meter, which you're not going to be able to, maybe a very, very large cathedral possibly would have that. You've got to be using 0.5 megawatt of electricity a year. If you can give me half-hourly data and the amount of electricity you use every half an hour, I can be much more accurate on what you're going to use. And I think that should answer that one. I keep seeing questions about mounting on a lead roof. Now, it's not impossible to mount on a lead roof, particularly if it's got a raised seam. If it hasn't got a raised seam, I'm going to need to refer. We'd need to talk a little bit more technical on that.
I've put into the chat the link through to the Historic England guidance, which includes
Okay.
the lead
Yeah.
mounting. And I've also put a link to our case study, which is a copper roof, which is a self-weighted system on a copper roof. So hopefully those are helpful.
Yeah, okay, that's fine. I mean, you know, if you need to puncture the roof, you puncture the roof. You just got to weatherproof the roof afterwards. So you need a specialist roofer to weather the roof. But does it make sense to also install ground source, air source, heat pump at the same time? Yes. The issue here is what you're using the ground and air source heat pumps for. If it's for space heating, of course, you only need space heating primarily in the winter when the PV system's not generating as much. If you're using it for cooling in the summer when the PV's generating a lot more, then you get a better benefit. But in round numbers, yes, a PV system is a good thing because your air source or ground source heat pump will be operating at a coefficient of performance of around about 3.5 to 4. And so if you're putting one element of 3 kilowatt of electricity in from the solar and getting 4 out for nothing, that's a good deal. But you need to work on the figures, Kathleen.
Now that's 10 past.
Right.
Let's just do the last 2 questions at the very top, which have got 3 thumbs, and then we might have to say we're sorry to the others that have got 1 or 2 thumbs. So
okay, I didn't quite.
How can we select a supplier without already having a technical? I don't quite understand that question, I'm afraid, Kevin. Do you understand the question, Guy?
No. How can you select a supplier? Right. If grant bodies require 3 tenderers. Well, I'm not quite sure what you mean there, Kevin. But
basically, to select a supplier, you'd go to the MCS accredited list.
Yeah.
You'd find 3 local providers and ask them to quote.
It. And you have to get a quote from the 3 companies. That's I think the way you'd have to go there.
And then the next one is to me, I guess, does the Church of England have standard text or statement of needs? No, we don't. We really look for it to be relevant and tailored to your church. You know, tell us why you need these panels. So tell us about how the environment is part of the life of your church. Are you an eco church? What have you already done? Have you tackled your lighting? Have you tackled your heating? You know, put the solar panel application in the context of what you're doing within your church to move toward net zero. Tell us about your electricity usage and how the panels will help you with that. Tell us whether they're going to help you financially to stay open and thriving as a church community. Make sure you tell us the actual technical details we know to judge a faculty application. So where will the panels go? Where will the inverters go? Where will the cable runs go? The practicalities. Is your roof in a good state? Those are the kind of things that you need to cover, but we don't have a standard statement of needs that you can take as a template, or at least we don't yet.
Just I could answer some very quick questions. The tilt does affect power. On a flat roof, 10 degrees is the minimum. We don't put them higher than that because they look absolutely awful, and the wind lift is huge on them. Anything vertically on a wall, the output is reduced quite significantly. A minimum of 10 degrees is required really for proper output. So you can mount them vertically. You need planning consent to mount panels vertical anywhere in the country. Is it only prudent to install panels? No, we install panels on all sorts of roofs. You just have to go through the process and make absolutely certain that it will structurally support it. If you are going to re-roof a roof, then really consider an in-roof system. It's substantially cheaper to install than a solar tiles, if they still exist. Do you recommend adding a battery if evening electricity use is significant? Possibly, just have to do the numbers.
I'm going to bring you to a close there, Guy. I know you want to answer everyone's question about everything, don't you? Yeah. But that is 1:15. We've had more than our money's worth from you today. Okay. Thank you so much, Guy, for presenting. I think that's been such a valuable session. As you can see in the chat, people have been putting in good comments as they've been leaving. Thank you to everyone.
Looking at those.
Guy, if you can send me over your slides as a PDF, I'll get them round to everybody in the next couple of days, and hope to see you all at a future session.
Fantastic. Bye-bye. Shall I leave as well?